to provide specific fuel mixture control of either a gasoline or diesel engine, and to accurately calculate EGR flow, it is essential for the intake air mass to be precisely measured. The hot film type sensor only needs to measure a small portion of the intake airflow to calculate the total air volume, while at the same time it can compensate for intake manifold pulsations and reverse airflow caused by the opening and closing of the engine's intake valves. How does this sensor work? Well, let's take a detailed look at this intake air measuring device. Hi, I'm Clint. The housing of the hot film air mass sensor projects into a measuring tube, which, depending upon the engine's air mass requirements, may have a variety of diameters. The measuring tube normally contains a diffuser, which ensures that the airflow in the measuring tube is uniform. The flow diffuser is generally a mesh design and is mounted upstream of the sensor. The key difference between a hot film and hot wire air mass sensor, apart from their physical properties, is that the hot film sensor measures a smaller portion of the air flowing through the measuring tube. Hot film air mass sensors have a serpentine and bypass channel formed as part of the sensor housing that the intake air must follow before measurement can take place. As air enters the sensor inlet, it is influenced by a deflector lip, also formed into the housing. This lip creates a low pressure area in the mouth of the serpentine channel. This results in a venturi-like effect in the channel, causing an increase in airspeed. Any residual dust or debris in the main airstream that passed through the air filter is not drawn into the serpentine channel, and instead continues through the bypass channel and exits the sensor. This system was devised to help protect the delicate sensor element from contamination of foreign matter. The heart of the assembly is the thermal film, which supports the intake temperature sensor, two measuring thermistors, and a heating resistor, all mounted on the same element. With the ignition on and the engine not running, the ambient air temperature inside the sensor is measured by the IAT. The heating resistor's temperature is then raised to around 120 degrees Celsius above this measured air temperature. Current flow is then measured through thermistor 1 and 2, and a calculation is performed by the sensor electronics to determine the airflow at this engine speed and load. In this scenario, as there is no airflow, the temperature of the film remains the same as the heating element. So, the current will be similar in both thermistors. A signal is generated and converted to a digital square wave with a fixed frequency. As this is a digital signal, there is no need for an analog to digital converter within this ECM circuit, therefore improving response times for air mass calculations. The ECM is able to quickly interpret the digital frequency and assign it a value. This is one of the main values used by the ECM to determine the correct injector pulse width, injection quantity, or EGR flow for the current engine operating conditions. Once the engine is started and running, the air sample in the serpentine tube flows over the IAT and hot film, which houses thermistor 1, the heating element, and then thermistor 2. The value of thermistor 1 can be calculated due to its current flow. At this point, the intake air is influencing the thermistor, so its current flow will be fixed. The airstream then passes over the heating element, where it takes on heat energy, raising its temperature. As the heated air passes over thermistor 2, its heat energy will be absorbed by the film and thermistor. The current flow here will change relative to the film temperature. The value of each thermistor is compared by the sensor electronics, and a digital frequency is generated. This signal is then sent to the ECM for air mass calculation. Changes in airflow and therefore air quantity over the sensor, will always produce a calculated value that is proportionate to the volume of air entering the engine. One of the problems all air mass or flow sensors experience is return airflow when the intake valves are closed. This occurs due to the rapid intake airflow coming to an abrupt stop when the intake valves are shut. The airflow tends to bounce back up the intake pipes and back through the air mass sensor. Unfortunately, the sensor does not know which direction the airflow is travelling, so it sends this measurement value to the ECM. The ECM then acts on this message and alters the injection pulse to suit these new values. By this stage, the engine's intake valves are open and airflow reverses direction once more, creating another measurement value for the ECM. This double measurement of air mass contributes to poor mixture correction and results in greater exhaust emission levels. Second generation hot film air mass sensors are able to recognise reverse flow, or the direction of intake air charge. When return airflow reaches the sensing film, it passes over thermistor 2, then the heating element, then thermistor 1. Due to the higher temperature of thermistor 1, the sensor electronics recognise that the airflow is in the opposite or reverse direction. The sensor will not send this incorrect information to the ECM. The PWM from the sensor will reflect the last known intake direction. Digital hot film air mass sensors are quickly becoming the first choice for vehicle manufacturers when designing cars to meet stringent emission targets. It's our responsibility as technicians to learn about this technology so that when it's time to diagnose, we don't get left behind. Thanks for watching.